In this video, we'll see how to find the formulas for sine theta by 2, cos theta by 2 and tan theta by 2. Theta by 2 is nothing but a submultiple. For any angle, say theta, theta upon 2, theta upon 3, theta upon 4, and all these things that come as a fraction are called as submultiples. To derive these formulas, we should know the formula for cos 2 theta. Let us recollect the formulas for cos 2 theta. There are three different formulas. The first one is cos 2 theta equal to cos square theta minus sin square theta. Cos 2 theta is also equal to 1 minus 2 sin square theta or 2 cos square theta minus 1. We'll use different formulas while deriving the submultiples. Let's start with sin theta by 2. For this, we will use cos 2 theta equal to 1 minus 2 sin square theta. To avoid confusion in the original formula, let us take a in place of theta. Then the formula would be like cos 2a equal to 1 minus 2 sin square a. Now in place of a, we'll substitute theta by 2. So this is the original formula. Here we have a, so we'll make it theta by 2. Even this a will make this as theta by 2. Let us write it down. From this, if we cancel out these two, then it will become cos theta. The required formula is for sine theta by 2 so that we will make enough transposition to the other side to retain only sine theta by 2 on one of the sides. So now first we will transpose this entire term towards the left hand side. This would be the thing here. After this, to retain sine theta by 2, first we will start transposing cos theta. This makes 1 minus cos theta. Here this is 2 into sine square theta by 2. So when we transpose the to the other side, it will become divided by 2. So sine square theta by 2 is equal to 1 minus cos theta by 2. We have to remove the square as well. So take square root on both sides. This gives the formula for sine theta by 2 equal to plus or minus root 1 minus cos theta by 2. Both the numerator and denominator are under root. Now this is the formula for sine theta by 2. Let us derive for cos theta by 2. For that, we will take the another formula, that is cos 2a equal to 2 cos square a minus 1. Here again we will try to substitute a equal to theta by 2. After substitution, it will look like this. Again, we have to cancel the 2 here. This makes cos theta. Adjustment to retain only cos theta by 2. So we'll start with transposing minus 1 to the other side first, and it will get modified like this. After this, we will transpose this 2 into cos square theta by 2. So this 2 into, when it gets transposed, it will become divided by 2. We'll take square root on both sides, and that gives the formula for cos theta by 2 equal to plus or minus root 1 plus cos theta by 2. Both numerator and denominator are again under the root. Now we know how to derive formula for sine theta by 2 and cos theta by 2. The next thing is tan theta by 2. For tan theta by 2, we have to know the formula for sine theta by 2 and cos theta by 2. Those things we'll use, as we know that tan is nothing but sine divided by cos. We'll use that here. Substituting this, tan theta by 2 equal to sine theta by 2 divided by cos theta by 2, and just substitute those values for sine theta by 2 and cos theta by 2. Here if we look this is like root a by b, which is nothing but root a by root b. So both numerator and denominator here will separate and write it down like this. Now again, this is the numerator and the denominator. Denominator is in form of a fraction. We know, as per the rule for division of fractions, while trying to divide with a fraction, we just have to multiply the numerator with its reciprocal. So we will take the reciprocal of this denominator and multiply with the numerator here. Now if we take the reciprocal, the denominator root 2 will come into the numerator, and this numerator here will get into the denominator, and in place of division we will have the multiplication sign. Root 2 and root 2 will get cancelled out, and we will have both the numerators here, giving the formula for tan theta by 2 as plus or minus root 1 minus cos theta divided by root 1 plus cos theta. This we can also write under the entire root like this: 1 minus cos theta divided by 1 plus cos theta. This is one of the formulas for tan theta by 2. We can still get few more formulas from this. Let us check that. So this is the final formula we have got just now. In the next step, we will try to multiply both the numerator and denominator with root 1 minus cos theta. Now when we are multiplying, if we multiply both denominator and numerator, there won't be any change. Here it is like root a into root b, which can be written as root a into b. Here both the numerator and denominator we will try to combine like that. Under root, here if we see this term and this term are same, so we can write it as like a into a, which can be written as root a square, and that would be equal to a, and that gives a simplification for the numerator portion. Coming to the denominator, this is like a plus b into a minus b. From algebraic expressions, we know this to be equal to a square minus b square, which means 1 square minus cos square theta. Let us write it down. So numerator is using this formula root a square, and denominator is using a square minus b square. So this root and square will get cancelled out, and we will have only 1 minus cos theta in the numerator. Coming to the denominator, from the Pythagorean trigonometric identities, sin square theta plus cos square theta equal to 1. From this, if we transpose cos square theta, we will get sin square theta is equal to 1 minus cos square theta. So in place of 1 minus cos square theta, we will substitute this sin square theta here. So this will get modified like this. Okay, for the numerator, we have just cancelled out the root and square, and then the numerator and denominator sin square theta. Again, the root and square, because of that, we will have only sin theta in the denominator. This is the second formula for tan theta by 2, which is equal to 1 minus cos theta divided by sin theta. Now we have got two formulas here. The third one, for that both the numerator and denominator, we will multiply them with root 1 plus cos theta. Again, these two are like root a into root b. So we'll make it as root a into b, and it will get modified like this. Now in the denominator we have two similar terms, that is a and a. So it's like root a into a, which is again root a square, that is nothing but a. So this denominator will get simplified to 1 plus cos theta. In the numerator, we have a minus b, where a is 1 and b is cos theta, and a plus b. So a minus b into a plus b is a square minus b square. Because of that, it will become 1 square minus cos square theta in the numerator. Let us write it down. Now, here in the numerator, again using this Pythagorean trigonometric identity, which says that sin square theta plus cos square theta is equal to 1. Transpose the cos square. This leaves sin square theta equal to 1 minus cos square theta. So in place of this 1 minus cos square theta, we can write it as sin square theta. And the denominator root and square. So we can just write the term itself. Let us write it down. So numerator we have written, and even the denominator 1 plus cos theta. Again the root and square in the numerator. So this makes tan theta equal to sin theta divided by 1 plus cos theta. So for tan theta by 2, we have got three different formulas here. In this video, we have seen the formulas for submultiples sin theta by 2, cos theta by 2 and tan theta by 2. These are the three main trigonometric ratios, and the rest three can be derived from these as those are reciprocals of these, like sin theta by 2 is equal to 1 by cos theta by 2. Cos theta by 2 is equal to 1 by sec theta by 2. Tan theta by 2 equal to 1 by cot theta by 2. Use those reciprocal identities and you can write the formulas for theta by 2 for the rest of the three ratios as well.